Next is to use predict probabilities. Okay? The predict probabilities for y equal to a certain response level, as we recall, is equal to the difference of two cumulative density function. And the probability for the cumulative probability, predict probability, is equal to this single cumulative density function as we derived when I went over odds ratio interpretation. So we can use some functions from user-written some user-written packages to calculate these predict probabilities. Okay. Now let me talk about partial change with respect to predict probabilities. Recall that this is the formula for calculating predicted probabilities. And what is the marginal effect? Or what is the partial change? So these two terms are interchangeable. Okay? Partial change means marginal effect. So the marginal effect of predict probability with respect to covariate is calculated in this fashion, right? So because these two, there are difference in cumulative density, okay? And we can simply use the addition subtraction now kind of law in calculus, right? So these two terms in the numerator can be separated to take derivative. And so this term, the derivative of this cumulative density function with respect to xk becomes beta k multiplied by probability density as opposed to cumulative, right? Probability density is first derivative of cumulative density, and that's for the second term. And we can factor out beta k. So that's used to calculate the partial change or marginal effect with respect to predict probabilities. Okay. And of course, we can calculate, for example, average discrete rates of change. Okay? That is for a certain amount of change in xk, we're going to observe how much going to change in the predict probabilities for a given response level of y. Right? So for 4 response levels, we're going to have 4 different numbers here, right? Yeah. And we're going to calculate for every single observation in our estimation sample, then average across. Again, this is a reminder for how to calculate probability for a response level. So how to calculate the average partial change or marginal effect? Well, since this is the formula for calculating probability, and average partial change or marginal effect is, the predict probability with respect to xk. And if you recall the partial change, it is beta k multiplied by this term, right? For a single observation. Here, what I'm trying to do is to make that calculation, to perform that calculation for every single observation. Okay, so for every single observation, we're going to calculate the difference of 2 probability density function multiplied by beta k for xk. Okay, then we're going to what? Add them up, then average across all these n observations in the estimation sample. Then we get what is called average marginal effects. Okay. Next, discrete rates of change, discrete rates of change, and discrete change. Okay, discrete change. So I should print it like this way. Discrete change is defined as, well, a difference of two probabilities. So for xk, here is where x, this vector, ends. Here is this where this xk starts, a particular covariate, right? We take a difference. Okay? The interpretation is when xk changes from the star value to the m value, the predicted probability of outcome m changes by that amount, holding all other variables at x. So all covariates should be held at fixed values. If we change the values of covariates, then the results are going to be different. And since the model is nonlinear, then the value of delta p, that is the difference in the predicted probability, depends on lots of things. First is the level of all variables that are not changing. Second is the value at which xk starts. Then is amount of change in xk. Okay, of course it relates to the value at which xk ends. Okay. Next, let me talk about discrete rates of change. When we talk about rates of change, we're going to take a ratio of some difference in y over difference in x, right? Over difference in x. So it is, the amount of change in xk, right? The ratio of, the difference in, the predicted probability for y equal to a certain response level over the difference in xk. Then the difference is calculated, well, by taking difference of two probabilities, right? And the interpretation is when xk changes from x starts to x ends, where x ends, the rates of change in predicted probability of outcome m is a ratio of delta p over delta k, holding all other variables at x, okay? Certain x values for the covariates, okay? We're not allowed to say holding all other variables constant, because when we say holding all other variables constant, that means it doesn't matter where those variables are constant, are held, okay? As long as they're held constant, right? Certain level, then the result's going to be the same. No, for nonlinear models here, when we calculate discrete rates of change and discrete change, we have to hold all other variables at certain fixed values. So since the model is nonlinear, the value of delta p over delta k depends on a couple of things. The level of all variables that are not changing, the value at which xk starts, the amount of change in xk. Okay? And note that when delta k is equal to 1, then discrete change is equivalent of discrete rates of change, because if we use delta p over delta k, if delta k is 1, then it is equivalent of delta p without dividing anything, right? And the values of other variables can be held at different locations. Some typical options are continuous variables could be held at their mean. Dummy variables could be held at both values, or either 0 or 1, depending upon our research interest. The star value and amount of change depend on the purpose of the analysis. Useful choices include, for example, xk change from its minimal to its maximal. Okay, let binary variables change from 0 to 1. Let xk change from the mean of xk to the mean of sk plus 1 unit, or let xk change from half unit below the mean of xk to half unit above the mean of xk. Or we can let xk change from the mean of xk to one standard deviation of xk above the mean of xk. That's one standard deviation, okay? Or we can let xk change from half standard deviation below the mean of xk to half standard deviation above the mean of xk. Okay, and this concludes my discussion about how to provide interpretation results from autoregression models, specifically proportional odds model. Thank you.